Welcome to the Energy Station. What we're doing here is we're trying to get the students to understand that energy cannot be created nor destroyed. We can only change the form it exists in. So we have several different examples of energy and how they are changed from one form to another for human consumption. The first thing we want to point out to the students is that energy can neither be created nor destroyed. We can only change the form it exists in. As humans, we eat food so we can store it in our body for later use. We call that potential energy. When you need it, your body can convert it to something more usable, for example, mechanical energy. Using mechanical energy, we're going to spin this bicycle wheel around. Please make sure the public only handles this handle right here, nothing else on the exhibit, because of the obvious hazards. So we're going to spin this around, which in turn will spin the generator. The generator takes that mechanical energy and changes it into electrical energy, which travels up these wires and lights up these light bulbs, which then become light energy. So we're going to be going from potential energy to mechanical energy to electrical energy to light energy, all in one device. So you go ahead and let each person give it a spin. So make sure you give all the students a chance to turn that and make sure they're only touching the handle, nothing else. Speaking of the flow of energy that we had from the bicycle and lights in our home, I want to show you how lights actually work. So when you turn the light switch on in your house, the electricity travels in a loop we call a circuit, and the lights come on. When you turn the light switch off, you open that circuit, the electricity can no longer make the trip, the light turns off. Now you can do this with the kids in a big circle holding hands and just have someone disconnect their hands to simulate the light switch going on and off. Next thing we have here is an example of the thermal energy in your body. It's called a hand boiler. This is glass. I want you to handle it carefully, but if you'll wrap your hand around this bottom part, the heat from your hand causes the gases to expand, which causes the liquid to rise. Okay, the next thing we have here is an example of insulation. Insulation can save a whole lot of energy in a home. In the Trailblazer, we have 4 inches of high density foam in the walls, the floor you're standing on, and the ceiling. So it's like we're inside of a giant igloo cooler. So if you allow the students to feel right here, they can feel the outer skin of the Trailblazer and see what the temperature would be like inside the Trailblazer if it was not for the insulation. One day we were in McAllen, Texas. The temperature was 107 degrees outside. We maintained 74 degrees in here all day long with over 250 people coming through because of our wonderful insulation. The next thing we have is our solar energy exhibit. On top of the Trailblazer, we have a sunroof which allows sunlight to come down and strike the solar panel. Solar panels change light energy into electrical energy. So we're going to allow the students one at a time to flip this switch, and we're going to watch this meter and see what happens. So you can see we're getting a very good flow of energy from the solar energy that's coming into the Trailblazer. Allow each of the students to flip this on and off, because as scientists we repeat the same experiment several times to see if we're getting the same results. Now we're going to do a what if. What if I were to take this book and put it on top of the solar panel? Do you think we'll still get solar energy flowing? Well, if you look at the meter, you'll see it is still flowing. The reason it does that is because when it's sitting here doing nothing, it's recharging solar batteries underneath the panel. Much like the landscape lights that you might have at your home, whenever it's dark or very cloudy, you can use the energy that you've stored up throughout the day. Have you ever noticed how the landscape lights tend to quit working after we've had 2 or 3 cloudy days in a row? That's because they haven't had the opportunity to store up any solar energy during the day. Okay, this is our wind energy exhibit. How many of you have seen the big wind turbines all over Texas? The way they work is because of the angle that the blades are tilted at. When the wind hits them, it causes them to turn. So you're changing wind energy into mechanical energy, which spins the generators behind the blades. Just like our generator over here, these convert mechanical energy to electrical energy and send it to our homes. So to give you an idea of the way this works, I'm going to give this a little bit of a head start. You can come one at a time and push this handle all the way in, and we'll see this start to turn, and you can see from the meter over there, we're generating quite a bit of electricity. Here's some interesting facts about the wind turbines most people don't know. The ones here in Texas have 3 blades. Each one of those is 84 feet long. That's more than twice as long as the trailer you're standing in. Okay, volunteers, at the end of each rotation of a group of students, make sure you take the opportunity to point to the career notations at the end of at the bottom of the circular signs. They tell us what kind of careers are available and what kind of money the kids can expect to make in those careers.